Hello everyone, I'm Dane Miller, and this is Lab 9 for ENME 351. So today I'm going to show you a temperature controlled fan that runs with a thermostat as my project. The most important part that I had to make was the temperature sensor, which is basically just a voltage divider with a thermistor as one of the resistors. The most involved process in this project was actually calibrating the sensor and coming up with the appropriate graphics to put into processing to show the current temperature as compared to the thermostat setting. So let's take a look at it. All right, so here's the setup. So the most important part is we've got right here, we've got our thermistor. This is basically just the voltage divider, and you got your power, analog output, and your ground. We've got the potentiometer right here on the left, and this has got power, analog output, and ground. This is what we're using as our thermostat, and this is just a little indicator that when our Arduino meets the proper conditions to output an activation signal to our H-bridge over here, then that indicator will come on. So the H-bridge is what I'm actually using as a switch to turn on power, and we've got our little DC brushed motor here with fan blades on it. I've selected brushed motors just because from a coding standpoint it's a little bit easier to deal with. And then we've got our external power, and this is hooked up to the same ground as the Arduino, and this is what's actually powering our fan. All right, so we're going to start up processing and we're going to take a look at this. So this is without the battery actually hooked up. So right here you can see our temperature data at the bottom, and then the thermostat right above it. We've got a legend up top, and this is our indicator down here. You can see it's currently in the off position. So this is pretty sensitive, so if I blow on this, my breath will actually heat it up enough that you can actually see the temperature spike, and once it passes the level that the thermostat's set at, it should activate the fan. This actually has a variable speed control, so at first it'll start at a low speed, and then if the temperature goes high enough above the thermostat setting, it'll kick it into high gear. So let's try it out. While that might have been an effective demonstration of the sensor, let's try it now with the battery pack actually connected. All right, so now that we're hooked up, let's try it. I'm not sure, you might be able to hear the difference between the high and low speeds. With the PWM engaged, there's actually a soft tone that you can hear. It almost sounds like a piezo electric transducer, like one of the little buzzers. So when this is actually hooked up to battery power, there's a little bit of interference. Part of that, I think, is due just to current flowing. It also seems to be due to some extent to the PWM that's controlling the low speed fan setting, because I tried this with a single speed setting and the interference was a little bit less, but it seems to work so far. So that's it. All right, so that's my whole project. I hope you enjoyed it. I had a lot of fun putting it together. It was a lot more interesting than doing the labs that are basically from a recipe, because I got to pick what I thought was important and make design decisions about it. So thanks for watching.